to give you a brief description of our BIM experience on the BERGEN Light Rail project. Just to contextualise it, Watt McDonald, we're a global engineering management and development company focused on guiding clients through what we see as some of the planet's more difficult challenges. We work in 160 countries, we're 16,000 staff, we're $2 billion turnover, and what I like is we have a heritage stretching back over 150 years. Where are we? About 50% of our people are in Europe, primarily UK and Ireland. We're well represented in North America. We're in Middle East, Southeast Asia and Australasia. We're not regional sectors. We work regional silos. We work across sectors. We go through advisory, built environment, energy, international development, transportation and water. This project was primarily transportation, but with a significant amount of built environment. So we married those two quite successfully. In Ireland, with offices in Dublin, Cork and Belfast, there's 150 of us, or more than that at this stage. Again, the sectors we operate in are primarily transport, water and power, that's what you know us for, but we're also involved in the built environment and in buildings. Within the overall Watt McDonald group, there's plenty of scope for BIM. We're fully committed to BIM. It is part of our core strategy. These are just two extracts from our internal intranet. It shows the level of guidance we have within all these areas. We have a whole series of documents telling us how we should do it, what we should do. On the right-hand side, we have separately had a Go Digital 2018 strategy for the last 4 or 5 years, and we're just about to achieve that. We're gone primarily digital at this stage, which is all part of the process. This was where our digital transformation was in about 2014. We've moved on a fair bit since then. So, BERGEN Light Rail, I'll talk a little bit about it from a project manager's viewpoint. How did it affect my life as a project manager in the project? And John will tell you more about the technical details. BERGEN Light Rail. BERGEN is a city about 60 degrees north, population about 300,000. Small for a light rail, yes, but the mountainous terrain meant that the development is linear, and that linear development is ideal for a light rail. The vision of the overall project, stage 4 and 5 future, is that 80% of the workplaces and 50% of homes in the entire city will be within 600 metres of a stop, which would be fantastic when it's fully rolled out. When we were appointed for stage 3, stage 1 is operational and stage 2 is still at design. More detailed look at the scope. There were 8 kilometres overall, there were 6 tunnels, there were 4 bridges. We had a significant maintenance workshop and depot. There was a parking hall there, a lot of snow in Norway in the winter, so you have to keep the trams warm at night. An administration building. In addition, we had a multiple-storey park and ride facility with the tram and the feeder buses interfacing on the roof of the facility. So, this is a project that is ideal for BIM. It's a no-brainer that you use BIM on a project like this. This is the overall programme. We were appointed at the beginning of 2012 for the main project and mid-2012 for the associated depot project. And the requirement to have the system operational by mid-2016 was a significant programme challenge, particularly when you take into consideration that our first task was optimising the client's concept design. A more detailed look at scope. This is the scope of the project. Our scope of services was full engineering, including architecture, including also the depots, maintenance depot systems, the specialist equipment in the depot. The signalling and communications were designed by other specialists for the client, but our system had to support those and take account of those systems. This then leads us to a project like this, trying to do it from Ireland. We won't do it like that. We need a broader resource, and our approach at Watt McDonald is to use the right resource for the job with much less focus on where that resource is, and BIM enables that. In addition to 10 Watt McDonald offices in 6 countries, we had Pascal and Watson providing the architecture, the RPA and RTII providing support on depot equipment, depot operations. We had some Norwegian consultants for some specialities in Norway. We had 354,000 hours logged on the project, which is the equivalent of 34 people for 4 years. 67% of that were Ireland-based people, and 75% was Mott MacDonald. Our overall project was BIM, using a CDE, but in support of that, we had extensive use of our Skype facilities, our internal PIMS project management system, and our internal but publicly available ProjectWise system. So the challenges facing a project manager at the beginning of a project like this: it's a new country. We had no initial presence there. BIM was a client requirement, and it was clearly defined as requirements, and that was a challenge to us, but it was also an opportunity for us. At the same time as we were starting our design, at the same time as we were trying to get our optimization going, we had to set up a local office, complete with IT infrastructure. Over the course of the project, between the client and ourselves, we occupied 7 different offices. And that didn't pose any real difficulties other than trying to negotiate with landlords. From our BIM side, it worked. We had to assemble a multidisciplinary team across the offices and countries. Again, as I said, it was based on having the suitable scale. As I said, we were developing the optimization stage while we were trying to get our BIM execution plan in place, while we were trying to hammer down the EIR, effectively get our BIM process running. We're starting from a project where we tendered, have a plan to do it, suddenly you win the project, and then you have to start running. And the client, not unreasonably, expects you to run fast from day one. As I said, we had a tight, fixed program, and compliance with program is a cultural norm in Norway. They can't understand why you don't achieve it. You said you would do it in a week. Why don't you? I think they're right. There was a tight, fixed budget. The budget was publicly available, so there was no change allowed in that. They had gone to international tender for stage 3 because they wanted what they were terming as effectively state-of-the-art technology. They wanted to bring in what they perceived to be the best available in the industry at the time. Their commercial driver, looking at the constructability of the project, ended up with having, with our guidance, 16 separate construction projects. So you have a project like this with 16 separate construction projects, and at the same time you're trying to develop your design through it. If you properly set up your BIM process, you can do it. But without a properly executed and set up BIM process, it won't work, in my opinion. All of this is my opinion as a project manager, by the way. How does BIM solve these problems? To me, BIM is one of a range of complementary tools. On this project, it was a client requirement with clear definition. We took an early decision not to set up a significant team in Norway. There were logistic and commercial reasons for that. Yes, you need face time with the client. Yes, you need face time with the stakeholders. Yes, you need face time with your project. But the team who will be doing this will change as the project develops. So if you're trying to put all of those into Norway, it's a huge commitment. You're much better off letting them stay where they're best placed and use digital technology and a BIM process to run a project like that. So for me, on this job, detailed use of BIM was inevitable. It was a no-brainer, and it worked for us. The media reported project outturn. This was in the local press 2 or 3 days after the project went operational in August 2015. The construction cost had increased from 3.6 to 3.75 billion kroner. That's about 400 million euro in real money. That's a 4% increase, which is not bad considering that there were fairly significant scope changes or additional scope within the project. To my mind, it was on budget. The official opening was on the 15th of August 2016, and the target had been the end of June. I say that's just about on time because I'm taking into account the fact that in Norway they have 5 weeks holidays in July, so it's the same as either just before Christmas or just after Christmas. To me, the BIM process and the application of it helped achieve an on-cost budget and an on-cost project and an on-time project. What were the benefits of BIM on this project? And again, this is just as I saw them, and it's taken a snapshot of some of them. First of all, safety. There were 3 different examples of this. In the depot area, line of sight is how the tram drivers will operate. So line of sight is important. But equally in the depot area, there was a planning requirement to have significant landscaping. So I have to match the 2. The ability to visualize the tram driver's view enabled that landscaping design. Tick the planning box, but at the same time maintain safety. Similarly, the line of sight visualization in the public areas enabled the designers to see what the tram driver would see, and that helps the design. It enables you declutter areas, it enables you improve safety of the system. If you're working outside the BIM process, you will have difficulty doing that. But it was fascinating to watch these models and see, oops, we can't have that there. Not that it's in the way, but you can achieve a better line of sight and therefore better safety. The Deerhoff Tunnel, this was interesting and unusual in that it was dealing with a tram line and a cycle track. You don't usually put those together, but we had to in this case. And they have conflicting lighting requirements. Tram wants it dark, cyclists want it bright. But with good modelling and able to see it, the engineers were able to develop an appropriate lighting solution that achieved and dealt with both sides. The advanced visibility of the final scheme. It was great to have the ability for the client, stakeholders and the like at an early stage to see how the project was developing, to have input into that project. It was selling it to the community, helped, dealing with stakeholders helped, and also the client understood very clearly what he was getting as the project was developing. Improved aesthetics. The developing model enabled, for example, the architects and lighting engineers to understand in the public realm area how both designs interfaced. And they were able to declutter as required and develop very good public lighting solutions. Integration with adjacent developments was key for us. The last stop on the line is at the newly constructed Terminal 2 in Bergen Airport, and this was a parallel project. And by having 2 compatible models that would talk to each other, after a little bit of pushing at the beginning, it greatly enabled that interface design. As well as that, when they were changing program requirements and construction sequences, the fact that both of us were working in a well-developed BIM environment greatly facilitated that. Also, along the route of the line, we had a number of different buildings which were under construction, under design, very close to us, and with good models, proper GIS mapping, and compatibility, that interface was made much more easy. And again, talking to the owners of those buildings, talking to the designers of those buildings, when you're talking in a model, everything is so much easier. At least it seems so to me. On the programme, yes, we had 16 different construction contracts, and yes, design was happening at the same time as those constructions were happening. Construction started in July 2013, but the detailed design continued until the end of 2014, and specialist design continued into 2015. But our clear BIM model and clear process gave credibility to the programme and the construction sequences, and this gave confidence to the tendering contractors, and they were able to reduce that element of risk within their tenders, which in turn is a cost saving for the client at the end of the day. Value for money. It's anecdotal, but for me, without question, it's value money for the client when you're designing in a BIM environment, when you're developing a parallel digital twin, when you're seeing how everything works, when you're seeing how effectively it comes together when you're dealing with your clash detection in a model before you start to go out to site. And we also benefited from having the client's input. The client had specialist teams on the project, and his people watching the model develop were able to work with it and interrogate it and contribute to the design as we're going along. They knew more about some of the elements than we did, so it made sense to bring in their skills and abilities. Quality, that to a certain extent is where the quality came in, the ability to draw the skills into a model and working together in a model. Did I miss one? We had a very smooth handover from the designer to the contractor. We had confidence in the design that was developing, and design was continuing while construction was going ahead. But because it was all detailed, captured in a proper process, and in the federated 3D models, it was clear to him, and the whole thing ran forward quite smoothly. For example, we integrated our BIM information into a cable management system. We designed the cable management system, and then with using an internal database, pulled all the relevant information for that together. John will talk in more detail about it perhaps. And with GIS mapping, we were able to give the client at the end of the day a fully detailed, fully located, asset-rich cable management system, which he then takes through to his operation stage. Reuse of waste material was important, and in Norway it's important to understand that rock is a waste material, not like here. There's so much of it, they can't get rid of it. And on a project, you really have to manage that. And with the BIM process and the properly developed models, we were able to use cut surfaces, excavation requirements and the like, to understand clearly how much rock would be available at all stages and managed through to try to reuse it. And bear in mind that we had 6 tunnels in the project, all delivering big quantities of rock by different contractors at different stages. Without a BIM process, that wouldn't have been possible. With the BIM process, you can reuse it and cut down cost. Our model use beyond construction, we have an awful lot of information within the model handed over to the client. I believe everything he needs is there, and my way of assessing that is that in our contract we have a 5-year defects period, not defects but effectively a period for which we're responsible beyond the operational date, the middle of August 2016. And so far we've had 3 very minor queries in a year and a half. We must have done something right. He must have the right information. Either that or he's just not talking to me anymore. So, what did I as a project manager learn from this project? Early detailed planning is essential, including getting a BIM execution plan up and running, hammering out your EIR at an early stage, getting a clear understanding, and also having a design development plan which matches both of those. It's critical to have suitable hardware capacity, internet connectivity, and telephony infrastructure available to you. In places we struggled at the beginning in times because our internet wasn't up to scratch, some of the telephone systems weren't up to scratch, and it took us a while to get that up and running, but it has to be right. Don't underestimate it, put some money aside to cover that. Another lesson for me was that buy-in by the whole team is essential. Any 2D only elements or any non-compliant processes are problematic. I know this poses a challenge to SMEs, but you can't have a BIM project that has outliers. It won't work, it'll pose problems. We had a few and we had to deal with them. I suggest that training and upskilling should be considered at an early stage. I think that in any project like this, we all need a little bit of understanding of what's happening. Future direction. John may talk a little bit more about the future direction, but I just took a look at another project in Mons that's more recent. It's at design stage. It is a JV for a Ariba 2 station design. And there was significant coordination required in a very complex project, probably substantially more complex than the BERGEN one. One of the things that I was interested and impressed with in that is that they used virtual reality at an early stage with random potential customers to get feedback on station set out, station operation, and it was done at a stage early enough to properly bring it back into the design. It's the 3D version of human factors, but it was important. It's showing the customer what he'll get, what he'll be using, hearing what he's saying, and taking it on board. I can go into more detail offline on this, but that team's recommendations for further work was that they believe model applications for requirements management need to be developed. They would like to see improved model-based coordination tools, and a direction that the software suppliers are probably heading is better automated model validation. It's not there yet, but we need to get there. For me, been positives, I've said once or twice, visualization and interaction with the client and stakeholders. It was great to be sitting in different offices, playing with the model, letting the client see what was happening. It's the way projects like this should work. Non-technical people understand models much better than 2D drawings. And in the past, we've thrown 2D drawings in front of people to say, isn't this great? They're not trained, they don't read them. The model they see, show them the model. As various people have said, clashes, more especially existing infrastructure, utilities and the like, can be resolved prior to construction, saving cost. In our case, we were interfacing with the utility companies, with the permitting authorities, and having clear model information, clear existing information, enabled early approval of what we were doing, again, all of which was important for the program. As I said, the good models allow better contractor understanding and visualization of the project. They're, as McViser is saying, as involved in it as we are. And with a good BIM model, you get clear communication of construction requirements to the contractor. He needs to understand your design, he needs to understand what you're visualizing, he needs to construct it. And the design and construction information, if properly developed, can be successfully brought through to the client for the operation and maintenance stage of the project. There's some negatives I think need to be addressed, or at least considered. We're developing skilled modelers. We need to maintain engineering and construction abilities. On projects notwithstanding BIM, we need full change management discipline. We can't change just because it's possible. You only change if you have to. At all stages, we need to understand the provenance and status of the models. Sometimes that's not clear to people, they don't understand. It must be clear, you need to understand what you're looking at, what stage it's at. Again, we need suitable hardware capacity, it must be there. You need a suitable CD set up, and with the CD, a clear understanding of ownership. That's very important, it hasn't been hammered out yet. It's going to be pushed around for a long time, but until there's that clear understanding of ownership, I think we have a problem. We need to allow for, and this is on an international basis, cultural and language challenges. It's not all English, it's not all UK oriented. And finally, application of BIM as a cost to engineering consultants, not always recognised by clients, but I'm glad to hear Paolo saying he's getting more aware of it. Finally, can I leave you with a thought? To me, design is in the mind. The BIM process helps the process, it describes it, it communicates it, but the design is in the mind. And this is just taking a single element of design and looking how it went through the BIM process. And to explain this, these are all extracts from earlier presentations during the development of the project. The depot is close to the airport, on an airport road, with a planning requirement for high quality architecture. At a very early stage, the architect is presenting his concept, a series of different shapes, and this shape represents the mountainous terrain. And the client's team bought into that, they liked that. That shape then becomes a space. Still sketched, but it's developing in a model. That space is developed in more detail, and this is a shot from the model, and at the end of the day, that becomes the building. And you can see the thread going the whole way through there, and that is enabled by BIM. So I'll let John talk to you about the more complex stuff. Thank you.
It that it's becoming business as usual. I think, you know, to be honest, different projects have different levels, but as a company we have the system set up so that effectively BIM can be delivered now. We're also looking at automation. We have a strand on data science, and we also have another service on smart infrastructures, smart cities and digital twins. So that's kind of, they're the other trends that are just as BIM becomes more mature. These are the sort of future trends that we're also looking at. But just to talk about BIM on the BERGEN project, that's quite an early shot. I suppose you had Jim showed you the scale of the project, and maybe just to show you the complexity, we have the way it was put up. I created this diagram just to help me understand. The organisations at the top are effectively the approval bodies, and on the left-hand side is the incoming requirements, the ground conditions, the existing system as it stands. And in the middle there is there's a sort of suite of about 14 different contracts. And the red ones were design was supplied by others, and the blue one was designed by Mott MacDonald. And the big blue package in the middle is really the main civil contract. And in fact, this is a sort of schematic, because effectively that civil contract is maybe over a 5-kilometre section, so there was maybe 6 of those types of contracts, then multiplying by the other packages. So when we started the job, the question was, you know, the client specified BIM, and the question was, well, how much does he need? And the key point for us, which I'll come back to, is that really you can really get bogged down in the detail if you're not you know, if you don't keep your eye on the ball. So really we kind of picked a view of the amount of BIM. On the one hand, the documentation would of course go through to our CDE, but on the other hand, the modelling would effectively be at the physical level of, you know, objects, cabinets, concrete bases, walls, structures. We weren't going to necessarily model every single component on things. So for some objects, some projects, some parts of the contracts, we went in more detail, but in general, as a bottom level, we asked all our design teams to model the main physical interfaces, the physical infrastructure, walls, surfaces, you know, lights, cabinets, things like that. And then having that model then allowed us a sort of base for the overall project. Just, I think, the distribution of the design teams, there's probably a lot of designers here with Dublin, Cork, and UK, Bergen, and also Eastern Prague and Budapest. Different disciplines were coming in. We also had, you know, collaboration with Pascal and Watson, who worked as the architects, and RPA, who helped with the depot operations. So the collaboration is kind of key to one of these sort of successful projects. And you know, to be honest, one of the reasons it was successful was that we had the design scope of the whole project. So in a way, we had it was our risk to do the collaboration. So, you know, sometimes when people fragment the whole contract structure and then ask themselves, where's the collaboration? It's harder to achieve, put it like that. So that was the project team, was very distributed. And this is, I think for me, this one shows the main benefit of BIM, which is really the fact that we have all these maybe 6 or 7 offices. And if you look at the bottom graph, if you can see that, that's sort of in quarters, like 3 months. So the point is, by having processes in place and design teams already available around the place, you can actually bring on teams quite quickly. So after, like, say, 2 months, we had over 100 people registered and working. I mean, they weren't all full-timers, but they're registered and working in the CDE, you know, within half a year of starting the project. And that that's the big benefit of BIM. You're talking about efficiencies, but not necessarily efficiency on one job. So it can be efficient for a design team because they can work on 6 or 7 jobs, and they're on and off the team. They're into the CDE, they're out of the CDE, and obviously when they're not needed on that project, they can just come off and go on to another job. So external collaboration. We also worked with client 3D workshops, and that's the other big advantage when we had BIM. We were able to produce models reasonably early on, and clients, and like especially with the language situation, clients are very interested in looking at progress, and it's a picture. It's more than 1,000 words. It just communicates exactly what you're trying to show, and sometimes what you haven't designed. That's another classic thing from a model. But it actually puts pressure on your own design team as well. So there's a kind of positive pressure. So just, I'm not going to get too technical despite what Jim said, but I would say this project was specified in 2011, and it wasn't called This is a Level 2 BIM project, but nonetheless within Mount Macdonald we were using the BS 1192 and PAS approach. So we did have the 4-stage workflow, and we we effectively had this was the way we had set it out. Effectively, we had, let's call it, types of people. We had the design management there with design planning, a delivery manager, an information manager. We had a sort of design block, which could have been a huge bunch of design teams, and then separately below that, then effectively there's a big site block of information as well. And then there's a sort of flow between those, and on the left-hand side, the engineering decision. What are we doing? Are we doing this change? Are we not doing this change? Is it a change? And then going up to the commercial stuff. So that's the kind of, I call it, organizational structure we had. And then we tracked we tracked changes and deliveries and issues, and this was like several years ago, so we had our own database for that. So just from a case study point of view, on every job that's separate, you have to look at what software you're going to use, because there's client never necessarily mandates the software itself. Obviously, we looked at the features of the software, the interoperability between our teams and their skills in the software, hardware network requirements, and client contractor compatibility. So with that, just to share, this was our software arrangement. This is 2012 to 2014. There's more higher versions of these software now. But effectively, on the left, we have the engineering sort of suite of design and modeling: MarkStation, Bentley MX, AutoCAD, Civil 3D, Revit. And then we had quite a big coordination function, and we had a CAD exercise which was taking DGNs and DWGs, and then we also generated, so we tried to do a lot of our design. Because it was a CDE setup, we could work in the CAD format directly, and the designers could link to other models directly, so they were working directly off the CAD. But then typically we exported it to Navisworks for big client interface meetings, and spinning it around, it's quite fast as well. And then, so that's the coordination function in the middle, and on the right-hand side you have your deliverables. We're producing PDFs, DWGs, as in 3D models, and Navisworks files as well. So it's approximately, I think, a level 2 structure. But that's it. So like I said, the key thing, which wasn't really specified in detail in the contract, but we kind of had to make a decision ourselves, was this level of development, level of detail, and this line, where you draw the line, because you had so many design teams and so many contractors. So we to be honest with you, the middle is shown there as, but often the one on the left-hand side, the 300, we achieved. I mean, we didn't model nuts and bolts, so we didn't really achieve 350. But I mean, an important point there is the contractors didn't need us to, because you have the model and the drawings. So there's always a step where you say, well, check the drawings, and that relationship between the two, it's how honest you are, how much have you actually modeled, really, and how much have you just sort of modeled. So, but if you've been quite honest about what you've modeled, and then the drawings is just the supplementary information, contractors reasonably happy with that arrangement. So I probably don't know time-wise. Just to touch on a couple of examples where having BIM was a benefit to people. So like Jim said, at the start of the job, we had an optimization phase, which isn't actually, normal. Well, that's not abnormal, but it's, let's say, unusual to get a contract and then be told, optimize it in your first phase. Usually it's, but I thought it was a very good idea. So we optimized about 50 points, and it was sort of design optioneering, but it was a fixed program, I think 4 months we had to do it in. So we were allowed, these are different, this is different scenarios for a track arrangement on the left-hand side, and then we scored on the right-hand side against, say, 8 dimensions. What's the preferred option? I think option 3 is more plus than minus. So this is a turn-back track arrangement. Then that was agreed, and we actually did some transport modeling as well. Then we did the design, basic design, and effectively that's the engineering design there, so it was done and proven. And then there was information days, so there was information model generated as well, which just put maybe some additional surface rendering and so on. And then just actually, I picked this one up yesterday because you can actually go into Street View now. So that's the final product, which is not too far away. This is another example where we have just to give you the flow. This was the original, like Jim says, your modeling and your sketches. It's really a cycle all the time between your sketches, your models, your design, and it kind of go around, and sometimes you go backwards and forwards. But this is the sketch of the airport terminus, which is sort of subsurface, and so there's passengers and elevators, that sort of engineering side of things. Then, because it's actually, modeling itself is quite easy usually. So in fact, we modeled the base, the tracks coming in, and then we were able to look at, the modeling didn't prove the pedestrian in this case. The model was maybe looking at the lighting and spacing and general layout. That's just the picture of the construction, and then that's actually last summer, and that's actually a real photo. It's actually it's a very sunny day in Norway. So, but so in a way, like with the modeling, you're showing something that people can see it in advance. There's a trust factor, and it's a chance that you can actually prove that a good design works as well. So you're making a case for a good design, and rather than everything optimization just meaning removing features that, sometimes optimization doesn't really, it's more like value engineering. So this was a true optimization exercise. That's just an example. Having the model, we were able to also quite easily add on a cable ducting system. So we had the whole thing in 3D anyway. So then we sort of procured a database system, and it allows us to do all the cable routing up and down the network, which the council liked because they had that same system for their city. So actually we handed them over a GIS. We actually just produced flat images to give them a GIS solution and a database thing, and then said there's all the cables, and that was the depot there, but then it was for the line as well. So that was kind of an added value thing. Another point is the models were obviously in 3D, and then we were able to produce, the contractor asked for a particular format, so there they just produced the bottom string of the ducts. So we produced that format in just a CAD format, DWG, and that was enough, the ducts in the corners, and for the contractor to, well, he had the package of drawings as well, but that was the data he specifically needed for his setting out information. And it was important to mention really that the thrusting part of the thrust behind the project, as far as BIM goes, was the client actually asked for BIM. He wanted this, this, and this, but he wanted BIM, and he specifically said he wanted the BIM to be developed continuously as a design tool, and then also used by the contractors for their construction as well. So it's kind of quite a simple brief, really only a page and a half, but the brief said what they wanted, and he didn't really get bogged down too much in standards. That's an example there of a track going under a road, and then that's the surfaces, the cutting out sections, and then this is that's a cross section of that example, which has gone into a excavation machine, and that's the excavator doing the work. But effectively, that's showing that they were working off the model information that we provided during the construction phase. The key I sort of had to summarize this. This is the kind of key benefits which we kind of know, shared understanding of the design, the very good for stakeholder interface, and then, okay, advantage to us was it was good for reputation, but I suppose it's good for the industry if we're doing projects like this. So I just summarized, and if anyone wants any questions afterwards, that's no problem. Just to summarize where we are at the moment. Well, no, just to summarize on that project. One point was the handover. As Jim said, we had an awful lot of different contracts, but the models created a level of trust with there was like 3 or 4 big civil contractors. They definitely did challenge us, but we were able to show, well, you have the spec and the drawings and the model. Now what's your question? So often actually there was things which weren't modeled, that was their question. But on the whole, the handover between design and construction was reasonably successful. Okay. So I would say on that case it was a design-only contract rather than design and build. So in that case we had the design-only contract. There was maybe 3 or 4 design and build suppliers, but on the whole it was a design-only contract. But we were coordinating against producing then packages for individual constructions. So that allowed us to deliver this. And I, to be very honest, on a much smaller job, there's not necessarily the scale to generate all these plans and processes. So probably the organisation, maybe like TII, maybe have to generate some of that themselves and say, these are our standards, that's our CDE. Now can you do this little job, sort of thing, rather than. Yeah. So I think the contract type was important to the speed of that design process. So where we are now, we have this the roadmap. So I suppose the government mandate this year. I suppose we're expecting, and I suppose the question will be, well, if there is a mandate, let's say announced, I suppose the question will be, well, what does that mean to designers? I suppose a couple of questions were. The designers or the contractors, even if level 2 is announced, I think they need some kind of standards in the background to justify. I mean, at the tender stage, they need some kind of guidance from the client on what they expect in a model, what they actually expect in drawings. What's their idea of a typical project. Otherwise, there could be 10, 15 tenders on a job. They'll all have different ideas, and how will you evaluate that? So in my mind, it's what I think maybe Stephen said earlier on, or Paul, was is BIM, is it building information management or is it information modeling? I know it's a question that you hear a lot, but if we focus on the management and forget about purely the modeling end of it, we'll actually be so generalized that when it comes to modeling, we won't be sure what we're looking at. So I think the two, they're separate probably, and they both need to be pushed. And in the Norway job, the Highways Commission had about 300-page standard on BIM standard. So although it wasn't the same as rail, we were able to, it was given to us as this is a guidance. So that was really, and Norway had the IFC there, sort of big behind that as well. So having some kind of standards to know where the level of actual data and modelling is needed is quite important. Otherwise, it'll obviously be a race to the bottom, I suppose. So also, I just mentioned on the contract types. I think if you have a design only and build, you allow maybe generates more time in the design process for just pure design decisions. Whereas if you're in a sort of D&B scenario, typically the design might be 5% of the cost. So it's very hard for a D&B consortium. It's very hard for them to take the purely singularly best design decision when everything else rides on that as well. So I think the contract type is important. Collaboration against competition. We like to. It's a challenge, and really, I think the people are here. That's why it's an industry trying to collaborate. So you just have to keep remember that and not be over competitive at the sake of sort of losing sight of things. And then also I think we shouldn't also lose sight that one of the big advantages of BIM is the construction savings. I know there's a lot of talk about the facilities management and all that and modelling, but we shouldn't lose sight of what's needed in the modelling for the construction phase and the timings. And that's, you know, I think honestly there are huge savings to be made there, and we need to remember that. Okay.
Hi, Jamie Mulcair from Rowbridge. I just have a question on classification. I mean, did you use any classification because it's a civils-based project with a lot of M&E interface? How did you manage that?
Okay, so fair question. There was actually there was two classification schemes. So there was a classification scheme in the buildings. So we had a depot and a big car park, and we used that classification scheme there. And then along the line, there had been existing kind of a railways type, a little bit more generic, but it had been developed on the previous phases of the project. That was a big spec in Norwegian. But anyway, we basically took that scheme and just reverse engineered that and then added that for this phase. So we had that scheme. That's as far as classification of object goes. There was drawings as well, which was using the coding scheme of the Norwegian road system. So yeah, it was adopting the local standards was the answer there.
Rob? John, it was interesting that you mentioned contract types there, and I think one of the interesting things that happened in the UK is when they re-looked at the work stages, they pulled out tender as a stage from the old RIBA work stages, because tender isn't actually a work stage. You don't sort of progress the design, because you can go, like Stephen, you spoke about procurement strategy. So if you're going IPD, for instance, you might go to tender on a brief at stage 1. And if you're going design build, you might go to tender on a set of scheme design documentation. And if you're going traditional design build, then you're going to tender on a more detailed set of technical design. So tender isn't a stage, but you know, the current RAI work stages and the current capital works management framework has tender as a definite work stage, which in a way almost embeds like a traditional design bid build procurement strategy in the process. So I just wanted to ask the question from a designer's point of view, and if we're beginning to rethink the way we procure stuff, like should we do something similar to the UK and pull tender out of work stages and allow different types of procurement strategy like IPD or design build? Or
I think from a designer point of view, once it goes to tender, then the reality is it becomes very difficult to change the design afterwards. So from our perspective, unless it's written into the tender that the design can change, tender is often the end of the design. So if that's why design and build is slightly different then, because the design is in the construction. But I suppose if you go from a BIM point of view, if you just go from stages 1 to 6 or 1 to 7, there's no logical reason why any of them is per se a tender as such. Of course, you're just developing the information. So really, you, in a more generic sense, you probably have 1 to 6 times how many things you're designing, and where you tender that is almost, I don't want to say irrelevant, but it's important, but it's in a different dimension. And it can tend to create a blockage in the design process. Of course, you have to design is one thing, and then you have to finish designing. It always comes to an end, and then you have to construct it, and then so there's a natural. But I think it should be thought about, and I suppose you could make it more flexible as to where you put the tender phases in.
Well, I was thinking more around, particularly around BIM, is this idea that you build the building twice, or you build a piece of infrastructure twice. So you've got to procure the digital version first. Now traditional, the way we traditionally do things, the specialist input can only occur post-tender. You can only get specialist input after they're appointed, which means that the the procurement of the virtual piece of infrastructure hasn't actually happened. You know,
so that's a paradox. Like you exactly have that. Like say a lot of our civil design we're able to do because we understand the equipment that's coming. So we'll do like the civil design, and we know there's going to be a procurement spec for, maybe OCS equipment or a cabinet. But we have a good idea what it's going to be. We'll do the design, but there's always a validation exercise afterwards. And obviously with the depot scenario, you're talking about bigger equipment, wheel lathes, lifting jacks and things like that. Typically you tend to slightly over design, but most objects have a rough dimensions, and then it's verified at the tender stage. But the closing out of the final equipment is a bit of a paradox in the sort of linear tender process. And it can only be done really, I suppose, by bringing samples of objects forward and doing. I mean, you can model jacks, you can model equipment in your 3D model and just say to be confirmed. And if your design is correct, unless you're designing right down to the millimeter, in which case you can't.
It can be done by paying people to build the virtual construction.
Oh yeah.
Yeah, more completely than.
Well, absolutely. The more your model is done, the more confidence you get.
But that's what we did to a certain extent, especially Superhunt. We modelled where it was going. We took sample and built it with an element and sense checked the flexibility for what we perceived to be the range of suppliers. If there was a supplier with a totally different idea that didn't match what was done, we would then have to go back to based around the sample and then sense checks the flexibility of it.
We have another question here and another one here. Yeah, I think because we're way over just.
Thank you. Leonard Sobiecki, representing Architectural Services in the Office of Public Works. Just maybe on the side of maybe more practical questions. I just wondered maybe if you could tell us a little about how did IT infrastructure operate on this project, and in terms of maybe the location of the ownership of the common data environment, and maybe expertise on the client side in terms of BIM, and like how did data transfer operate, from your organization to the client?
If I talk about the ownership hasn't been tested. We believe that we have the ownership, and when we're finished, we hand that ownership over to the client. But there have been various tests of that concept, and the result of those tests is still out there in the legal domain. On other projects, I'm aware that there's been a test of rules and ownership. But in our case, we own the design for it, and the ownership became an issue because there was an argument that land always have access to it, and then when we finished, it became his, and he had people with sufficient skill to control and understand what we were doing, so that when we handed him the model, he got exactly what he expected. Steve Bessett, that you had a quote from there, was their lead guy, and he just watched us, married us the whole way.
Last question, John. Have to say short one. Or I'm not getting your results.
I need to get my master's. Okay, so a very quick question. First of all, well done to John and Jim. Brilliant presentation. Very important case study produced as well by CitA on this for what is very, very complex project work in linear infrastructure projects. My question is, you mentioned the EIO was produced and it was a 1.5 page brief, which sounds quite shocking, but what asset information requirements were requested at that stage? And just if you can give me a brief synopsis of that.
Well, it was within the scope of works was the design section, and the asset. I mean, effectively, it looked for a 3D modelling throughout the course of the design and handover, and They were looking for a civil 3D eventual product, because I think originally the first half of the job was the line, so that they saw it more as a linear project. So eventually they wanted a 3D model handed over, I mean, they didn't specify IFC's levels of detail, but there was a negotiation at the start of the job where we said what we'd do. It was tested at the contract stage prior to award, so there was a bit of back and forth. But I think the concept was they wanted the model for design and for use during construction. They're very clear about that, and that's the way we did it.
I did note that one of the challenges we had was developing a program plan, the design program, carrying out the EIR, getting offices set up, assembling a team, and getting the design all rolling at the same time. It took a while for that to smooth out. It's one of the lessons learned. In a different, better project, all of that will be time. Does that make sense?
It does, yeah. Thank you.
Okay, so I think we'll have to draw it to a close there. I'd like to thank John and Jim very much for that really interesting case study, which of course is available to view online. So there's a link in the email that was sent around to everybody. So if you join me in giving them a round of applause.